everybody. I'm glad we could all be here together in our new strange way of doing our classes here. So welcome to our first week back, and we will see how this goes. All right? So what I have for you here is a lecture, that just like the lectures we have every week, and you will have your lab book out, and you'll be filling in the blanks like we have in the past. Now, this is a video that is going to be sent by way of YouTube. And the reason I've done that is because I haven't been able to get the Zoom and the recorded PowerPoint to play any videos. And I really depend on videos and wanted to add those to it. And I think they add to our lecture. So we're going to go this route. We'll see how it works. If we want to do a Zoom for a classroom, just to have some interaction, I'd be really open to that, to doing that, just not the lecture. I've been using Zoom with my church, and I did some tests, some practice things, and it turns out that sometimes it kind of glitches, and somebody drops off, and then somebody has to come back in, and then the audio's off. Anyway, it's a little confusing. And I'm a little nervous to do that live with y'all, and so I'm going to see how this recording thing does. Okay, great. So the last time we were together in general science, we were talking about digestion. You remember that? It seems like a long time ago, doesn't it? Yeah, so we started that in lab module 13A, and now we're going to be on 13B. So we're continuing to talk about the digestive system. Our lab today is a little different. We're actually going to play a game, and so that, as you can imagine, is a little difficult to do remotely. So what I'll do is I'll have the game up here, and I'll just be asking you questions essentially, and it'll help you prepare for the quiz, which brings up the quiz. I'm not exactly sure how we're going to administer that. Apparently the Google Classroom will be useful for that, and possibly you could go in to the Google Classroom and actually take the quiz online. All right, so we're still checking into that. We'll see. As time goes on, I really hope I'm able to video some of our labs and put them into here, but honestly, I think we'll be back in the classroom. I think we'll get back together. You're not going to get out of that rat dissection, y'all. Okay, we're going to do that, right? That's how we end this unit. So I really want to be back together when we do that. So we'll see how that goes. I tried taping, video with my phone, and like if I wanted to do a lab or something, and that I don't. My phone's just not good enough for that. So while it taped it, it wouldn't send it. So I'll have to see how that works. I can always use this camera right here for that. I'm working on getting a better microphone pretty soon. So hopefully, if the sound isn't great, then hopefully when a new microphone comes, everybody wants a microphone right now. So it's kind of delayed in coming. When I get that, maybe it will help with the audio. So just be patient with me. We're in this together, right? We'll get through it together. No worries, no problems over here. I hope everybody's feeling well. I'm well. My family are all well. No illnesses over here. So I'm really looking forward to getting back together with y'all, though. So I hope that works out. And next, get ready for your lecture. Have your book open, ready to go. It is a video. You can pause it whenever you like. All right, you can rewatch it if you want. It's going to come over from YouTube. So I'll send out an email with this soon, and then I'll communicate with your parents about if we need to make some changes. Because if we need to just send the video to you, supposedly you can open that with your video player. Okay? All right, so here we go. See y'all soon.
Okay, so this is my new microphone. I hope it sounds good. Here we are. This is the week we are in right here, week 26. We're going to finish digestion today. The liver won't work out since I couldn't find a liver in the grocery store. Kind of weird what kind of things are available. Then we'll move on to 14, the circulatory system, the respiratory system. I had dissections scheduled for those. We'll see how I can manage those, and you can maybe remotely dissect them with me. Then we go to 16. Remember, I moved this where 16 comes up so we can look at 16. We have a couple of labs over here, but there's no labs for 15 really, so that's why I moved that. So our rat dissection could be at the end after we'd spoken about everything. That's the only reason I did that. Notice our final exam is scheduled for that last day. I hope we're back together by then. It is the sit down with the, multiple choice, similar to the midterm, like that. If we are not back together, then we'll have to figure out a way to administer that. Okay. So digestion continued. It seems like a long time ago that we were talking about this. We started in the first part speaking about the stomach, and I remember going a little bit out of order. Do you remember that? So I had you open to part A and then part B, so we might have to have a little order situation here. Okay, so remember the digestive system. Here's a little bit of a review, all the parts. So last time we talked all about the actual gastrointestinal tract. That would be the esophagus, the stomach, the small intestine, the large intestine. So that was part of 13B. Remember, I had you turn over there. So we've already covered that. So we're going to now today talk mostly about the accessory organs. So I think on your lab book, if you're turned to page 64, and at the top it says liver functions, that's where we're going to get started. But the first thing we're going to do is have just a little review video. So here we go.
Across the whole planet, humans eat on average between 1 and 2.7 kilograms of food a day. That's over 365 kilograms a year per person, and more than 28,800 kilograms over the course of a lifetime. And every last scrap makes its way through the digestive system. Comprised of 10 organs, covering 9 meters, and containing over 20 specialized cell types, this is one of the most diverse and complicated systems in the human body. Its parts continuously work in unison to fulfill a singular task, transforming the raw materials of your food into the nutrients and energy that keep you alive. Spanning the entire length of your torso, the digestive system has 4 main components. First, there's the gastrointestinal tract, a twisting channel that transports your food and has an internal surface area of between 30 and 40 square meters, enough to cover half a badminton court. Second, there's the pancreas, gallbladder, and liver, a trio of organs that break down food using an array of special juices. Third, the body's enzymes, hormones, nerves, and blood all work together to break down food, modulate the digestive process, and deliver its final products. Finally, there's the mesentery, a large stretch of tissue that supports and positions all your digestive organs in the abdomen, enabling them to do their jobs. The digestive process begins before food even hits your tongue. Anticipating a tasty morsel, glands in your mouth start to pump out saliva. We produce about 1.5 liters of this liquid each day. Once inside your mouth, chewing combines with the sloshing saliva to turn food into a moist lump called the bolus. Enzymes present in the saliva break down any starch. Then your food finds itself at the rim of a 25 centimeter long tube called the esophagus, down which it must plunge to reach the stomach. Nerves in the surrounding esophageal tissue sense the bolus's presence and trigger peristalsis, a series of defined muscular contractions. That propels the food into the stomach, where it's left at the mercy of the muscular stomach walls, which pound the bolus, breaking it into chunks. Hormones secreted by cells in the lining trigger the release of acids and enzyme-rich juices from the stomach wall that start to dissolve the food and break down its proteins. These hormones also alert the pancreas, liver, and gallbladder to produce digestive juices and transfer bile, a yellowish-green liquid that digests fat, in preparation for the next stage. After 3 hours inside the stomach, the once shapely bolus is now a frothy liquid called chyme, to the gallbladder, which secretes it into the first portion of the small intestine, called the duodenum. Here, it dissolves the fats floating in the slurry of chyme so they can be easily digested by the pancreatic and intestinal juices that have leached onto the scene. These enzyme-rich juices break the fat molecules down into fatty acids and glycerol for easier absorption into the body. The enzymes also carry out the final deconstruction of proteins into amino acids and carbohydrates into glucose. This happens in the small intestine's lower regions, the jejunum and ileum. which are coated in millions of tiny projections called villi. These create a huge surface area to maximize molecule absorption and transference into the bloodstream. The blood takes them on the final leg of their journey to feed the body's organs and tissues. But it's not over quite yet. Leftover fiber, water, and dead cells sloughed off during digestion make it into the large intestine, also known as the colon. The body drains out most of the remaining fluid through the intestinal wall. What's left is a soft mass called stool. The colon squeezes this byproduct into a pouch called the rectum, where nerves sense it expanding and tell the body when it's time to expel the waste. The byproducts of digestion exit through the anus, and the food's long journey, typically lasting between 30 and 40 hours, is finally complete.
All right, that's a really great overview. So watch that a couple times before taking your quiz. Honestly, a lot of the questions are answered right there. One of the key words I wanted you to that since we talked about it last time, but that word peristalsis, that talks about the muscle action pushing the food down the esophagus. It's also the action in the stomach and the intestines pushing the food along. So that peristalsis is very important. You may recall the last time we were together, I explained that even if you were standing on your head, your food would still go down into your stomach because of that muscular action of peristalsis. Same as if you were an astronaut with zero gravity. When you swallowed, it would still go down into your stomach because of that muscular action. Gravity helps some, right? But it's really our body's beautiful design that is capable of doing that. Okay, so now we're going to look at the accessory organs. You can see them here in this picture. We have our liver, which is huge, one of our largest organs in the body. We have the pancreas tucked behind the stomach here, right? There's a pancreas. The pancreas we're going to see is also very important in the endocrine system. So when we study hormones in the next module or the last module, module 15, we'll talk about the pancreas again. And then, of course, our great little gallbladder right here, which is tucked underneath the liver. And we're going to see what all of these things do for us. But that's how they're arranged in the body, sort of all packed together because they're all working together right there. So let's start with our liver. The liver has lots and lots of jobs that it does. It is incredibly important. I don't know, liver is an organ, and some people eat organ meat. So some people eat liver, which is why I should have been able to find some liver at the grocery store to show it to you. But I'm not sure if you've ever had it. Some people don't like it. I'm not a big fan. But it has a very, interesting texture, sort of like an eraser, sort of that kind of thick, dense tissue in there. Well, it turns out that in our body, the liver, which is very large, is one of the few organs that actually does regenerate. All right, so if part of your liver gets removed, for instance, then it'll start to grow back. And furthermore, if you need to give part of your liver to someone as a donation, if you will donate an organ to them, the liver is one of the most successful transplant organs out there. Furthermore, if you transplant a kidney to somebody, if you also give them part of your liver, when you give them that kidney, you transplant that as well, it confers a higher success rate on the original transplant. So liver's pretty amazing, all right? So at the top you see it says here, love your liver, be good to your liver. So let's see some of those functions right there. It looks like your book has 1, 2, 3, 4, 5 functions. 1, 2, 3. And I have 6. So you may want to squeeze one more of those in there. Okay, so first of all, the liver makes bile. Okay, bile is a chemical. It is, we'll watch a little video in a minute right here, but it's kind of a greenish, yellowish, emulsifying chemical. So it's, you can maybe think of it a little bit like soap. I know that sounds weird, but if you're washing dishes that are greasy and oily, if you put soap on there, it breaks that up. Well, that's exactly what bile is doing. It's breaking up fats. So the way that we can digest fats is by emulsifying them with bile. All right, that's made in the liver. The liver also stores sugars and fats, And when it stores them in something known as, oops, didn't mean to do that, as something called glycogen. All right, so glycogen is basically stored glucose that is stored there in the liver. It waits there for you if you need it. So if you are getting hungry, then your liver will break down some glycogen to give you a quick access to some glucose so you can continue with the respiration process. It also stores fats in there. So if I need fats for some reason, our body can go into the liver and break them down and use them from there. Next, it converts amino acids into energy. So if you recall, and from that video you just saw, the amino acids are the building blocks of proteins. All right, so typically we use proteins to build new protein, and that is to build muscle and things like this. But here the amino acids can actually be converted so that they can be used for respiration. They can be used for the Krebs cycle, producing ATP. Remember, that's the energy we're making. ATP is for adenosine triphosphate, and our body is all about making energy. All right, next, the liver is a detoxifier. So if we've been exposed to anything, any toxins at all, they go to the liver and the liver breaks them down and gets rid of them. The liver will warm your blood to regulate your temperature because it's such a large organ. It's very vascular. It has a lot of blood supply to it, and it actually will warm you up. It is the old RBCs. You remember what those are? Those are red blood cells. We may not have talked about those. The red blood cells will go to die in the liver, so they're removed by the liver. It turns out red blood cells have a very short lifespan, about 4 months, and after that they go to the liver to be gotten rid of. So now we're going to watch a little video on this.
The liver is an important organ that sits just under your rib cage, mostly on the right side. It weighs about 3 pounds and is made up of 2 separate sections called lobes, the right lobe and the left lobe. By looking at it under a microscope, you can see that the liver is actually made up of billions of liver cells. 2 major blood vessels, the hepatic artery and the portal vein, continuously bring blood to the liver cells. This blood is important because it allows the liver to perform many important functions, like filtering waste and poisons, processing nutrients, and storing fuel for your body. First, the liver cells filter waste, bacteria, and poisons out of your blood and change these toxic substances into safer ones. The liver also helps change certain medicines into forms that your body can use and then get rid of. Processing nutrients is another function of the liver. Most of the food you eat is eventually processed through your liver before your body can use it. After you eat, your food is broken down into small particles called proteins, fats, and carbohydrates. Your blood carries these building blocks to the liver, where they are used to make and store many of the nutrients your body needs. For example, proteins are broken down into smaller amino acids, which the liver then combines into new proteins. There are many kinds of proteins, each with a specific size, shape, and purpose. Proteins are important for many bodily functions, such as clotting your blood when you get cut. Your liver also makes cholesterol and stores fuel for your body, such as vitamins and carbohydrates and minerals. On a regular basis, your liver sends proteins, fats, cholesterol, and vitamins into your bloodstream to be used for energy and building healthy tissue. Finally, your liver also makes bile, which is a fluid that dissolves fat. This takes place in the small intestine. Fats need to be dissolved so they can be absorbed into the bloodstream. In order for bile to get to your small intestine, the liver cells are connected to small tubes called ducts that eventually come together to form a larger passageway. This passage, called the bile duct, carries bile from the liver to the gallbladder, which is a holding area for the bile. The bile is then eventually delivered into the small intestine. Because the liver does so many important things for your body, you can't live without one.
All right, there we go. So, like he said in the video there, you can't live without your liver. You can live with just part of a liver, however. You'll see on the left over here, we have a healthy liver. Looks really good, like one you would buy in the store, right? And then this is an unhealthy liver. Okay, so if you have, for instance, if you are putting too many toxins into your body, it'll overwork your liver and it will cause it to get hardened. And that's what cirrhosis means. Cirrhosis means to harden it. And if it's hardened, it can't do its job very well. And then you may get a disease. You may get what is known as hepatitis. Hepatitis just means an inflammation of the liver. Sometimes that's caused by viruses. Sometimes it's caused by damage. And so keeping your liver healthy is good. That means not taking too many toxins in. Toxins would include medications for one, drugs, illegal drugs, we're never going to do those, alcohol, those would all be considered toxins that can do damage to your liver. So you have to be careful. Now, if you have damage, okay, you may end up with this condition right here. So notice the hand on the right looks very yellow. And the hand on the left is normal. That's the normal flesh color. So this yellowing of the skin, yellowing of the eyes, like the white part of the eyes, that is called jaundice. And jaundice is a condition that it indicates a problem with your liver. So what happens, that bile that's formed in there and other chemicals, a chemical called bilirubin, happen to have that yellow color. And if your liver is not functioning properly, that yellow color will be manifested, will be shown through your skin. And this is a good warning sign that you have problems with your liver and you need to go get it taken care of. So how do liver problems, how are they taken care of? Well, we have medications for some things. You would, of course, be instructed not to be putting any more toxins into your body. And then at the last case scenario, of course, would be getting a liver transplant, which I explained earlier is actually a very successful type of a transplant. But avoid that by keeping your liver healthy. Now we have our pancreas, which we saw in the picture there. Remember, it was situated kind of behind the stomach. And it is also involved in making hormones, very important hormones. So we'll talk about it again. But in the digestive system, it's responsible for making some digestive juices, some pancreatic juice. And that juice will go in and start to break down and start to work on the chyme in your stomach to make it so that the intestine can absorb it. So it produces a base. A base is something that's the opposite of an acid. So remember, our stomach had a lot of acid in it. Remember that? It had hydrochloric acid. And so in order for that chyme to be less acidic when it gets into the intestinal tract, the pancreas will put these juices in there, which is sodium bicarbonate. Same thing as baking soda. So if we have the acid in your stomach plus the base here from the pancreas, it transforms that acid to water and salts. So that's good, right? So now the acidic chyme will not damage the small intestine. So it neutralizes the chyme from the stomach. It also makes something called lipase and amylase. These are enzymes. They help break down fats and sugars. Here's that picture of it. So this is a cutaway here. So think of the stomach as kind of right over the top of it right here. And so the stomach would be joined to this deal right here, this little sphincter. And then we can see, look at the gallbladder and that duct, the bile duct. This is called the common bile duct. It gets down, goes through the pancreas. The pancreas also has a duct, the pancreatic duct. And both of these, the bile and the pancreatic juices, are released right in here to the top of the small intestine, called the duodenum or the duodenum. And it'll be dumped right in there, straight out from the stomach, and therefore neutralizing that acidic part of it there. All right, you can see here the duodenum then would go down into the small intestine right there. So it secretes enzymes that help digest proteins and fats and carbohydrates as well. Once again, the picture shows those beautiful little ducts right there, these specialized cells that are going down the duct into the duodenum right there. And those special cells are the ones that release these special enzymes. Bringing us now to the gallbladder. The gallbladder stores and concentrates the bile. So remember, where is the bile made? Remember, it's made in the liver, okay? And it's only stored in the gallbladder. And the reason it's that way is when we need it, when we have a very fatty meal, then we'll have this nice concentrated, remember, soapy type substance that will then be ejected into the duct, down into the intestines to help us digest our fats. And that's as needed, right? So it turns out you can actually live without your gallbladder because the gallbladder is not making the bile, but it is storing it. So it turns out that there are many people that have had trouble with gallbladder disease. Sometimes we have a collection as it's concentrating it. So think about this. The bile's made, and what does it mean to concentrate it? That's going to mean to take out some of the water and make the bile more and more strong, so stronger and stronger by removing water. And so sometimes when that happens, there's a chemical called cholesterol that can be formed in there that's being stored as part of the bile. And as the water gets taken out of it, for some people, then that concentrated bile will actually solidify into little stones. You may have heard of something called gallstones. And so the gallstones can actually be in the gallbladder, which honestly, if there are stones in there, it's not a huge problem unless the stone tries to go through the duct right here, and it'll actually clog that duct up. And sometimes it will cause the gallbladder to have spasms, and some people will have gallbladder spasms even without having any gallstones, and those people, it can cause great discomfort for them. I think we'll watch a little video here in just a minute. And that will, some people will have their gallbladder removed to get rid of the stones or to remove that discomfort right there. Because of where it is under the liver there, sometimes there's a pain involved, and that pain almost mimics a heart attack or something. So someone might think they're having a heart attack when really it's just a gallbladder spasm. And so removing the gallbladder will remove that difficulty. And here's our little video about it.
It's a 4-inch pear-shaped organ that sits in the upper right corner of your abdomen, right under your liver.
The liver produces bile, and the bile drips down into the gallbladder, and it's really an organ to store the bile. And then when we eat, the gallbladder squeezes and pushes the bile into the small intestine, and that helps to break down the fat content of our food and start digestion.
But if a patient develops gallbladder disease, they may have a range of problems from inflammation to gallstones.
So we can get small hardened deposits that form in the gallbladder, and those stones themselves can then over time become a problem.
Most patients with gallstones show no symptoms, but there are those who have pain, nausea, and vomiting.
And it doesn't happen every day. It can come and go, and they will typically find that a fatty meal can trigger that.
While the cause is unknown, health experts say there are risk factors if the patient is obese, has high triglycerides, or is pregnant. Studies show 6% of men will develop gallstones, while 9% of women will develop gallstones. But patients without symptoms rarely undergo treatment. Once the symptoms start, patients may undergo surgery to have the gallbladder removed.
Liver is still going to produce bile, and you'll have a constant slow drip into the small intestine so that you can emulsify the fat in your food.
But without a gallbladder, patients need to be cautious of eating a fatty meal. For Lee Health, I'm Lindsay Fry.
All right. So that discussed the health of our gallbladder there. So the next picture I'm showing you, I wanted to give you a little warning here, is a removed gallbladder that has gallstones in it. Yikes, look at that. Okay, so you can see how these stones have formed, and they've solidified some cholesterol and other chemicals and things. Notice this really large one right here. It's near the bile duct. It was probably blocking it, probably causing great discomfort. Some people, when they have this, they'll just feel like after eating a meal, they'll feel nauseated, and things like that, which can indicate gallbladder disease. Hopefully you won't have a problem with your gallbladder, but remember, you can live without it. All right, moving on now to nutrients. So we're going to be looking at the micronutrients and the macronutrients. I guess we looked at the macronutrients last time, right? And so now we're looking at the micronutrients. So the macronutrients would be proteins and fats and carbohydrates. And remember, when they say carbohydrates, they're talking about sugars. Okay, so now we need other things to help with keeping us healthy. These would be considered micronutrients. All right, so if any of you take a multivitamin, that is to get some of these micronutrients in there. Notice up here it says to eat your vitamins. It is really, really great to get your vitamins from a food source. But sometimes our food sources are lacking really good vitamin content. It has to do with really the way we farm now, and we've sort of stripped a lot of the nutritious value from our soil that our plants are growing in. And so sometimes we really will need to supplement by taking some vitamins extra instead of just getting them from our food. But I'm going to show you here some of these vitamins and where we can get them from our food. So the first ones we're going to talk about are the fat-soluble vitamins. So you're going to write these down. What are the fat-soluble vitamins? They are vitamin A, vitamin D, vitamin E, and vitamin K. So fat-soluble means, of course, they are dissolved by fats. And this is why you need healthy fats. So let's start with vitamin A. Okay, vitamin A is essential for good eyesight and healthy skin. Vitamin A is a very helpful vitamin for that. If you've ever seen, remember the Bugs Bunny cartoons, and he eats lots of carrots, right? So vitamin A is in carrots, and he says he can see really well because he eats that, right? So it turns out that vitamin A is found in many things that are orange colored. Orange. So we have carrots, have a lot of orange coloring in them, right? Sweet potatoes are orange, peaches are orange, but also eggs and kale have a nice amount of vitamin A in there. So if you can find these and eat these, especially if you can do it organically, get organic produce, then you will be getting vitamin A for yourself. Okay, next is vitamin D. Vitamin D, we actually make vitamin D ourselves. It helps for strong bones and teeth. It also is just useful for other bodily functions as far as just keeping your metabolism running smoothly. It also fights infection. So if you are sick or concerned about getting sick, then taking vitamin D would be a good idea. But like I said, we actually make vitamin D in our body by converting it from our skin. Okay, so there are precursors in our skin that get activated in the sunshine. Okay, so vitamin D is the sunshine vitamin. So getting some sun on your skin is so good for you. Now that we're cooped up in the houses and stuff, make sure and get outside on a sunny day. You know, sun can be damaging too. It can burn you, so don't get too much sun. But some sun is so good for you, and it's one of the reasons is because it converts that vitamin D. Vitamin D helps you fight infections, so getting sun on your skin keeps you well. How about that? We have added vitamin D to some things. For instance, milk typically adds vitamin D to it, so we can get it. You can find it in tuna. You can find it in eggs, once again, specifically in the yolks. I actually take a supplement of vitamin D. It's a fish oil. So fish oil is one of those places you can get vitamin D as well. Next, we have vitamin E. It's an antioxidant. Antioxidants are useful in helping to break down toxins and keeping our body healthy. Notice it says keeping our DNA healthy. We can find vitamin E in oily things like avocado, God's gift to the planet right there. Avocados are wonderful for you. Other oils, I would stick with natural oils. Avocado oil is really great. Olive oil is fantastic. I would stay away from manufactured oils like canola oil and things like that. Green leafy vegetables and some nuts also have vitamin E in there. So spinach, nice good organic spinach would be good for you. Vitamin K, once again, this is one that we can make in our body. It is hugely responsible for blood clotting. It actually assists in the process of the cascade of events that allows for blood clotting, which we'll learn about in module 14, I think. it turns out we make them with bacteria in our gut. Okay, so our gut bacteria will make this vitamin K. We need to make sure we have healthy gut bacteria. So how do you make sure you have that? Well, one of the ways is that's very popular right now is to take a probiotic, which actually puts bacteria back into your intestine and keeps it nice and healthy. So that's good. You can also take vitamin K as a supplement, and it's going to help with much more than just blood clotting, but it also helps keeping you well. All right, next we have our water-soluble vitamins. Notice you only have 2 blanks there. That's because it's vitamin B and vitamin C. These are the ones that will be dissolved in water. This is why you need lots of water. It's just a bigger chart here for vitamin B because it turns out vitamin B has several different aspects to it. All right, so vitamin B is great for your metabolism. It keeps everything functioning smoothly. It's like the oil in the machine that keeps everything going nice and smoothly. Oftentimes, if people are struggling with fatigue, that means they're tired all the time, they might just need a good boost of vitamin B. Vitamin B will get you feeling really, really good. Not all the vitamin B we can take as a supplement is the same. Some of it doesn't get absorbed really well. And so you have to kind of shop around and find out a really good absorbable, bioavailable vitamin B for yourself. All right, so B1 is also known as thiamine, and you can find that in legumes and whole grains. So remember, legumes are anything in a pod, right? So anything like a pea in a pod, a green bean has a pod, peanuts are in a pod. Those are all considered legumes. So really any kind of beans. Whole grains would be, of course, your whole wheat and things like that. B2 is called riboflavin, and riboflavin can be found in meat, legumes, once again, dairy, and, oh, interesting, asparagus. How about that? If you look on a label of food, so a processed food, let's say breakfast cereal or something, you might see these listed out as thiamine, riboflavin, niacin, that kind of thing. So next is B3, it's niacin. You can find that in red meat and in peanuts, once again, a legume. How about that? Looks like legumes are really good for us as far as vitamin B goes. B9, also known as folate, legumes again, dried beans, which are legumes, and other legumes. Asparagus, once again, how about that? Let's have some asparagus today. B6, I guess, is just called B6. We can find that in potatoes. Hooray, potatoes are healthy. Bananas, beans, once again, seeds and nuts. Many seeds and nuts are also considered legumes. B12, we can find in milk, cheese, and eggs. So right here, look at all that great stuff we can eat for some good vitamin B acquiring there. Vitamin C, you probably know a lot about that. We know that vitamin C is one of those great things to keep us healthy. It helps our immune system to be strong. It helps our bones, our teeth, our blood vessels, all these things. So our blood vessels would be our vascular system. It keeps our blood vessels nice and strong without getting weak and clogged and things like that. So we can find vitamin C in yummy things: citrus fruits, strawberries, broccoli, tomatoes, spinach. A lot of people take vitamin C, tablets. So maybe you remember chewing these up. They were orange flavored, and they kind of taste good, sort of like a sweet tart or something. So the good thing about both of these, vitamin B and vitamin C, is that you can't get too much of them. Because they're water soluble, if we have too much in our body, we just get rid of it through the urinary system. Okay, but some of the fat soluble ones, on the other hand, those can actually collect up and stay in the fat of your body, so you can get too much of the fat soluble ones, the ones we talked about previously. So I know in the past I've heard of people getting too much vitamin A, and that can store up, and it can start to actually cause some problems. Remember, too much of a good thing can sometimes be a problem. All right, there it is. Can you get too much of a good thing with vitamins and minerals? Yes. So you take your supplements the way they are recommended. Don't think, well, if one of these is good, then 2 must be better. Don't go that route. Make sure and just follow the instructions that are given on the label. Yeah, so in moderation for a nice healthy. Remember, try to get as many of these things as you can through your food sources. So let's go over that again. Right here, we're looking at some vitamin A-rich foods. Notice a lot of orange color going on in there. So if you wanted to get some vitamin A today, maybe have a sweet potato or a salad with kale and carrot. Although I will say kale is best if we cook it. Notice the squash is like a butternut squash. Cantaloupe, yum, right? That's a good source. Dried apricots, interesting. Dried apricots are almost like eating candy, right? Vitamin B over here, look, trout, yum. Lean meat, whole wheats, beans, peas, seeds. These are all those legumes I was talking about. So that's B1. So those are some of the rich foods where you can find that. B2 and B3. All right. So, oh, look, cheese, yum. We can get cheese as some of our B2 there. Almonds and eggs. Interesting. Anybody want some squid today? Does that sound good to anybody? We call that calamari when we cook it. Spinach. Mushrooms, yay. B3, look, we have our avocado. Everybody should have an avocado today. Tuna. This shows like a tuna steak, but also tuna fish. We have red meat, beef. Oh, look here, the liver. If we decide to eat some liver, right, we'll get some B3 from there. Peanuts, turkey meat, it turns out. Vitamin K. Oh, good. I listed here the other things that vitamin K do for us. Of course, they help regulate blood clotting. We know that right there. But also, reduce the risk of osteoporosis. Osteoporosis is when our bones become weak. Oftentimes, elderly women have this problem, and osteoporosis will cause maybe them to be leaning over and sort of a humpback kind of a thing. Also, the bones are more brittle, and they will break more easily. Lowers the risk of bleeding in the liver. Interesting. Okay, so that's probably part of the clotting thing right there. It aids in blood sugar regulation. We know it helps with blood clotting, yes. Hemorrhaging, here's clotting again. So in the newborn, it's interesting that newborns don't start making vitamin K until about the first week is over. About day 8, in fact, is when they start making vitamin K. And that's because when the baby is born, there's no bacteria, right, in their gut because they've been in mama the whole time. So it takes about 8 days for that bacteria to establish itself. It comes from living in the world, you know. The baby now has stuff putting in his mouth, and the mouth will have some bacteria taken in to it, down into the gut, and then that gut bacteria will start making vitamin K. It also boosts immunity, and that's where a lot of people like to take a supplement to boost their immunity and even their digestive health. So let's see where we can find it. Over here, we've got green peas, tomatoes, avocado, broccoli, lettuce. Oh, yeah, I've just now become a fan of Brussels sprouts. I never did like them. I don't blame you if you don't like them. They're kind of bitter tasting. But you put a little vinegar and bacon on there, and it makes everything better, right? Spinach, once again, look here. It looks like we could have a nice salad with some avocado and tomato and then get a bunch of vitamin K that way. And then maybe some fish. So how about fish and a salad? And Brussels sprouts, yay. Vitamin E, let's see. Here we go. Vitamin, interesting, it says here helps to prevent cancer, aids in improving metabolism, beneficial in preventing cardiovascular disease. I think we mentioned that, how it will help our blood vessels stay strong. Aids in reducing and delaying growth of cataracts. That's in your eyes. So vitamin E is also good for your eyes right here. So where can we find vitamin E? Papaya. By the way, papaya is really good for digestion as well. How about that? Sunflower seeds. There we go. Avocado, once again. See, God's gift. Asparagus, we knew that. Broccoli. Dried apricots again. That's interesting. I'm going to have to get some dried apricots. Squash and pumpkin. I guess that's squash right there. Almonds and spinach once again. All right, so we've seen some really healthy ideas for lunch today. Vitamin C, some of the most delicious of our vitamin supplements right here. So we have strawberries, oranges, lemons, guava. Interesting, that's this fruit right down here called guava. When I was a kid, my mom used to eat guava paste. It was sort of a concentrated guava, like a gel, and I thought it was gross. She loved it, though. It was kind of very sweet, kind of sugary, that kind of thing. Helps prevent scurvy. Yeah, that is where when you don't have enough vitamin C. Scurvy is when like your gums start to get real fragile and they start to bleed, and you can lose your teeth, stuff like this. Scurvy was experienced by sailors. Sailors would go off back in the old days on their ships and go sailing for a long, long time away from any port, and they didn't really think about bringing any fruit along. When they started to figure out that and they'd get scurvy is the point. And that's why you say, you scurvy, pirate or whatever, because they're on the sea. And when they realized that vitamin C, I don't know if they figured out it was vitamin C, but they realized that citrus fruits helped scurvy. So they started taking limes. Limes last a long time. And these sailors would be chewing on the limes all the time, which would help with scurvy, and they ended up being called limeys. So that would be another name for a sailor. It helps cure, interesting, lead toxicity. Okay, so we get lead just inadvertently in our life. It's all around. Once again, helping our eyes with cataracts. Lowering hypertension. Hypertension is high blood pressure, so it helps high blood pressure, brings that down. Relieves symptoms of asthma. Prevents cancer and heart disease. Protects against cough and common cold. It is very good for your immune system. Yeah, like I said before, so taking supplemental vitamin C, lots of people do that. Iron is, it's literally a metal, but if you recall, it is iron that is in our red blood cells. We haven't actually talked about that, have we? Okay, but iron is important to get the oxygen in our blood to our tissues. Okay, we'll talk about that in the next module. It helps apparently cure insomnia, interesting. Keeps our muscles healthy, increases your brain development, treats anemia. That's part of the blood thing, right? It's getting the oxygen to the blood. Anemia is a lack of oxygen in your blood, and so iron, of course, holds on to it. Cures restless leg syndrome. Regulates body temperature, and it helps the formation of hemoglobin, which is the protein in your blood cells that's holding on to the oxygen once again. So iron's a good one. We can see over here we've got it available in many things that we've already eaten right today. So we've had our spinach and our apricots. Who knew apricots were so healthy for you? Pumpkin and pumpkin seeds. Our culture isn't as big into eating pumpkin seeds as other cultures, and they really are very good for us. They're called pepitas in Mexico. Legumes again. Look, raisins, onions. That's good to see that onions are high in iron. Broccoli and almonds. Oh, look here, it tells us it keeps our hair follicles growing. So that's good. That means our hair, we won't get bald as easily. Calcium. Calcium is good for strong bones. Here we go. Also these things. So bone health in the center, but we have helping prevent kidney stones. Interesting. Preventing colon cancer. Yay. Here we have what we call PMS. Teeth and gum health. And blood pressure control. So all very good. What do we have high in calcium? Sardines. I don't know about y'all. Not a big fan. I don't know what pigeon peas are. Almonds, though, I'm good on almonds. I'm good on spinach. Orange juice. Blackstrap molasses is kind of like a very, very thick, syrupy. I don't know. It's sweet. It's naturally sweet. It comes from sugar, I think, sugar cane. We have milks here. Some soy. Sesame seeds, cheese, hooray, yogurt right here. So those are all high in calcium. All of our dairy products. I don't know why they don't have milk on the list right here, but milk would be one of those as well. All right, it's lab time. I'm going to play this little video for you.
Here I am ready to teach, okay? You know, we got to be careful, right? We got to have our personal protective equipment on to make sure we don't pass that virus through this screen right here, right? Because we all know that viruses can go through the computer, right? Yeah, we got to know that. So, hold on. All right, April Fools. No, viruses don't go through screens like this. Furthermore, I'm not sick. Okay, so I'm going to start our lab here in just a minute, and we'll see how it goes. Great.
Okay, I couldn't resist. It's April Fool's Day on Wednesday, right? So I was just doing a little goofy thing for you there. Now, next we're going to see our lab. Remember I told you it was this game. So, sorry, this doesn't translate very well onto the video, but I'll just essentially be reading a few questions for you. They're really good to get you ready for next week's quiz, and I'm still working on how to get that quiz to you. So I'm going to play this for you, and this will be our lab.
All right, we're going to try to play a little bit of this game right here, okay? So we're going to go through, we're going to start up here at the stomach, all right, and come through. Next comes the small intestine, all right? So we're going to go here, down through the small intestine, and then up now through the yellow part here is going to be the large intestine, and then out. So when we played together, the first person who got to the end would be the winner if we actually got that far. But
But mostly it's about sort of a little competition and learning some of the answers to some of these questions. All right, so I'm going to roll. It's a 2. And on our game, and even if it doesn't have a question mark, I'll go ahead and we're going to ask a question. So here's our first question. The salivary glands contain enzymes that begin the process of chemically digesting A, proteins, B, fats, or C, carbohydrates. Remember, we learned about proteins, fats, and carbohydrates as our macronutrients. Any guesses? All right, the answer is C, carbohydrates. Carbohydrates, because of that amylase in there. Okay, and so if one of you had got the answer to this, if one of you missed, I'd let somebody else give it a shot, and then you get to earn one of these, a Digesto buck. And at the end, whoever has the most Digesto bucks and then gets to the end, like if we all get there about the same time, then we add up the Digesto bucks, and you are the winner. Okay, let's get to our next one here. 3. 1, 2, 3. All right, our next question. The enzymes called pepsinogens aid in the digestion of A, proteins, B, lipids, or C, carbohydrates. Do you remember what lipids are? Lipids are fats, right? And so our last answer was carbohydrates. Listen to the word pepsinogen, like Pepsi, like peptic. All right, the answer is proteins. Proteins. All right, only 2, my goodness, 1, 2. Here we go. It's not as much fun playing this game all by myself. During digestion, proteins must be broken down into smaller units called, this is a good question, y'all, it's a good quiz question. What are proteins made up of? Anybody remember? It's amino acids. Amino acids. 5. 1, 2, 3. Notice I'm going to go through the old, the new. What am I trying to say? The small intestine. 4, 5, and it's going to go through. Remember, small intestine is really long, but it's narrow. What is the name of the part that secures the tongue to the floor of the mouth? I don't think we covered this one. We only have 2 choices. That we have the uvula and the frenulum, and I'm just going to give you that one. I'm going to tell you that one is the frenulum. We didn't study that one. Let's get a different question. Okay, define the term digestion. This is really good because I've told you what digestion is. Remember what it is? Here's our definition. Changing food substances into forms that can be absorbed. And the way we put it was breaking foods down. Breaking food down. That's digestion. All right, 5. 1, 2, 3, 4, 5. Amylase enzymes aid in the breakdown of A, proteins, B, lipids, or C, carbohydrates. We actually already had this one, and I told you that answer on our first question. The answer is C, carbohydrates. All right. 6. 1, 2, 3, 4, 5, 6. What is the full capacity of the stomach? How much can it hold? A, 4 liters, B, 5 liters, C, 1 liter, or D, 10 liters. What do you think? Well, it's probably not 1 or 10, right? Those are too small and too big. So any guesses between 4 and 5? The answer is 4. 3. 1, 2, 3. Okay, here's our question. The fancy name for the roof of the mouth is called the palate. The palate. The hard palate and then the soft palate. All right. 2. 1, 2. The enzyme lipase breaks this down into usable units. Look at lipase. Lipase. Is it proteins, lipids, or carbohydrates? The word lipase sounds a lot like lipid, so guess what? That's the answer. Lipase breaks down lipids. All right. 6. 1, 2, 3, 4, 5. 6, I'm in the large intestine now. Remember when the small intestine joins to the large intestine, there's this little part right down here called the appendix. It's hanging off the beginning of the large intestine right there. Let's see what our question is. The name of the folds found in the stomach lining are called, this is the folds of the stomach lining. Are they A, villi, B, rugae, or C, papilla? Now remember any of those words from our last 2 lectures? It was actually not this lecture, but the last one. It's rugae. Rugae is the right answer. 4. 1, 2, 3, 4. Here's our question. The portion of the small intestine that connects with the large intestine. Ah, we're right there, huh? Small intestine to large intestine right here. Do you remember the parts? There are 3 parts of the small intestine. And that third part that connects right down there, it's either the ileum, the duodenum, or the jejunum. Do you remember? All right. The top part is going to be our duodenum. Then comes the jejunum, then the ileum. So the answer is ileum. The 3 parts of the small intestine. That'll probably be a question coming up. So remember that. 6. 1, 2, 3, 4, 5, 6. Here's our question. All chemical digestion of food is completed in this digestive system organ. All right, chemical digestion. What this means by chemical digestion is absorption. So where in the system is absorption taking place? Anybody remember this? It's also from the previous lecture. It is in the small intestine, right? The small intestine. That's where all the absorption takes place. 5. 1, 2, 3, 4, 5. When the skin takes on a yellowish tone due to the accumulation of bilirubin, it is called A, cyanosis, B, jaundice, or C, flushing. We just talked about this today. Yeah, the liver's not working right and you turn kind of yellow. Remember that word? It is jaundice. You become jaundice. 4. 1, 2, 3, 4. True or false? The liver is the largest gland in the body. Okay, that is true. So many things done by the liver. All right, next, we're getting to the end here. 1, 2, 3, 4, 5, 6. We're at the finish line. Let's see our question. The finger-like projections that line the wall of the small intestine are called, you don't even have a ABC on this one. You remember those little projections that come up, and they make it kind of look velvety, and they increase the surface area? Those are called villi. Villi. All right, so at the end, of course, we would have added up Digesto-Bucks. It would have taken more time. Let's ask a few more questions here. Which part of the digestive system stores bile? Anyone? The gallbladder. Which of the following is not a part of the large intestine? Cecum, jejunum, or colon? It's B, jejunum, because that's part of the small intestine. Okay, what color is bile? Green. True or false? One of the jobs of the large intestine is to absorb water. Very, very true. That's its main job, in fact. True or false? One of the liver's jobs is to remove damaged red blood cells. Answer, true. Bile helps in the digestion of what? Anybody remember? We talked about it today. The digestion of fats. Okay, just a couple more. Which of the following is not an accessory organ of the digestive system? A, the liver, B, the spleen, or C, the pancreas? In other words, which one of these have we not talked about? That would be the spleen. The part of the stomach that connects the to the small intestine, it's either the fundus or the pyloric or the body. That's a tough one. It's from last time, which 2 weeks ago. That is B, the pyloric. The pyloric, sphincter is right there. On which side of the body would one find the appendix? Look at your picture here. So it's right down here. What side is that on? That would be the right side. If you have a appendix problem, you would have pain on the right side. Okay. The first part of the small intestine is called the A, jejunum, B, ileum, or C, duodenum or duodenum. The answer is C, the duodenum. All right. When the stomach's enzymes and acid eat away at the stomach lining, these can form ulcers. All right. And I think we're about done here. What's the type of acid found in the stomach? It's hydrochloric acid. Yeah, I'm not going to go longer than 10 minutes. What's the name of the flap that keeps food from entering the trachea? That's the epiglottis. Okay, gang, I'm going to end there. These should be good questions to help you study for your quiz. Sorry, it's kind of a crummy lab for this one. We could have looked at some liver, but the liver was all sold out at the grocery store. So, all right. See you soon. Bye. Okay, so that's it. We're done with the digestive system now, and just kind of go through and study those things, study your book, and get ready for the quiz next time. if we had played the game, I was planning on giving you the winner a prize, and it would have been an avocado. Hooray. No, I'm kidding. We probably would have had something better than that. All right, so I will see y'all or contact y'all next week about our next lab. Okay, thanks, guys. Have a great week.